On December 2, 2024, the United States escalated its tech battle with China, adding 140 entities to its export control list, a decisive move aimed at crippling China's ability to produce advanced semiconductors. The Bureau of Industry and Security stated this was a proactive measure to hinder Beijing's military modernization. In swift retaliation, China announced export controls on critical materials like gallium, germanium, and antimony, essential for tech and defense industries worldwide.
China has banned the export of some materials essential to the manufacturing of electronics and some military equipment to the U.S. It comes in response to Washington's chip sanctions on Beijing. CBS News.
While tensions between the U.S. and China over trade, technology, and national security had been simmering for years, a major inflection point came on May 15, 2019. On this day, President Donald Trump issued an executive order effectively banning Huawei, China's telecommunications giant, from doing business with U.S. companies, citing national security concerns. Over the past years, these measures have increased. August 17, 2020, the U.S. further tightened restrictions on Huawei, aiming to cut off its access to commercially available chips made with U.S. technology. June 3, 2021, President Biden expanded a Trump-era ban, prohibiting U.S. investment in 59 Chinese companies with alleged ties to defense or surveillance technology sectors. October 7, 2022, the U.S. Department of Commerce announced sweeping export controls aimed at restricting China's ability to obtain advanced computing chips. October 20, 2023, China announced export controls on certain graphite products, citing national security concerns, further impacting the global supply chain for battery production. And the latest one was on December 23, 2024. The Biden administration launched a probe into Chinese-made legacy semiconductors under Section 301 of the 1974 Trade Act, aiming to protect American semiconductor producers from China's state-driven chip supply buildup. These are some of the few steps that both countries taken thus far. While all these measures are tit for tat, just look at the amount of measures taken in 2024. It is higher than any other past years. But China's ban on rare earths marks a significant shift because it targets a critical choke point in global supply chains. Banning these minerals to the U.S. didn't happen overnight. May 2019, just after U.S. ban on Huawei, China hinted at restricting rare earth exports as a countermeasure against U.S. sanctions on Huawei. This was not formalized, but acted as a warning. Then, in the same month, Chinese President Xi Jinping visited a rare earth mining and processing plant, signaling the potential use of rare earth elements as a geopolitical weapon. After that, in December 2020, China considered export controls on rare earth minerals critical for U.S. defense contractors like Lockheed Martin. Then, in the following month of January and February of 2021, reports indicated China was preparing to cut off rare earth supplies to U.S. defense contractors. On July 2023, China imposed export restrictions on gallium and germanium, signaling a shift toward leveraging critical mineral exports as a policy tool. Finally, on December 2024, China imposes its most stringent critical minerals export restrictions yet, which is further tightening its grip on critical minerals. Rare earth elements are a group of 17 chemical elements that occur together in the periodic table, 15 lanthanides, scandium, and yttrium. These all are metals and have many similar properties which often cause them to be found together in geologic deposits. They are also referred to as rare earth oxides because many of them are sold as oxide compounds. Rare earth elements are not rare in quantity. Some of them are very abundant in the Earth's crust. For example, cerium is more abundant than copper and lead. However, their extraction is very difficult. Rare earth elements possess unique electrical, catalytic, magnetic, and luminescent properties, making them vital for a wide range of applications. They are being used in anything and everything that comes out as an innovative product nowadays, such as computer memory, DVDs, rechargeable batteries, cell phones, catalytic converters, magnets, fluorescent lighting, and much more. The extraction of these elements are the most environmentally negative and toxic generating of all mining practices. Disproportionate rare earth mining has resulted in landslides, clogged rivers, environmental pollution emergencies, and even major accidents and disasters, causing great damage to people's safety and health and the ecological environment. Currently, China holds 40% of the global reserves of rare earth elements. As mentioned earlier, rare earth elements are not truly rare, so reserves are not the primary issue. The bigger issue lies in the production of these elements. Beijing controls nearly 70% of the global production of rare earth elements, which is significant, especially considering that the second largest producer, the United States, controls only about 12%. Some materials, like gallium for example, are critical. Gallium is a soft, silvery metal used in the production of LED screens. It is also utilized in more advanced products, such as automobiles, solar cells, and next-generation weapons. China is currently the largest global producer of gallium, producing 600 tons in 2022 and controlling 98% of gallium exports. In addition, China is one of the world's largest semiconductor producers. While the U.S. imports these products from China, it also trades with countries such as Canada, Germany, and Japan. These countries supply the U.S. with gallium, germanium, and antimony exports. Given China's production capacity, the U.S. remains vulnerable when it comes to these critical minerals. So, can the U.S. survive these bans? As you can see, this problem does not have a quick solution. Starting production of these elements could take years. However, while building up to that, the U.S. can manage. Here's why. United States can rely on the purchase of semi-processed materials from other countries like Japan that buy directly from China. As this is currently happening, halting exports of critical minerals can backfire. By doing so, the U.S. can invest in other parts of the world to obtain these minerals. A similar situation occurred with Japan in 2010 when China banned the export of rare earth elements to Japan for 2 months due to a territorial dispute between the two countries. As a result, the Japanese government supported Lynas, an Australian company, in developing a large rare earth metals mine as an alternative supplier. The U.S. can restart the production of these metals. The United States has not mined its own gallium, used in semiconductors, since 1987, and this presents an opportunity to change that. This map shows the current state of rare earth production in the United States. As you can see, there isn't much activity at the moment, but with the right investments, production could significantly increase. While the U.S. works to minimize the impact of a ban, the future implications are significant. The prices of these elements are likely to rise. For example, gallium is a byproduct of aluminum production, and the reason China can produce gallium so cheaply is due to its massive aluminum production, which reduces the cost of extracting gallium. Additionally, cheap energy is another reason China can create these metals at low cost. As the U.S. lacks these advantages, the prices of these elements are very likely to increase. In fact, antimony prices have risen by 200% this year due to the bans. This could have major implications for the global economy, as these metals are found in nearly every electronic component. Another challenge is the massive environmental pollution associated with these elements. In Pennsylvania alone, drainage from coal piles and abandoned mines has turned waterways red from iron ore and turquoise from aluminum, killing life in more than 5,000 miles, 8,000 kilometers, of streams. Problems like these add to the challenges, and it is up to policymakers to decide how to address them effectively. Addressing these challenges will take a combination of investment, innovation, and collaboration with global partners.